Good morning, everyone. In this video, we are on page 4 of the practice set, looking at this third problem where we have a polynomial. Now here, we're gonna make a sketch from our calculator. So I went ahead and typed this equation into my y equals, and when I hit graph, I see this. Now, the problem is I can't see the whole graph, so I'm not really sure what all is going on here. So I'm gonna go ahead and hit zoom fit, which is option 0, and see what that shows me as far as my graph goes. That's much better. So I'm gonna go ahead and just sketch this on a little coordinate plane here. So it looks like I'm going like this, and then I come back down, and then I go back up, making sure we put arrows on our sketch. Now, folks, before we get into the increasing and decreasing and max and min stuff that we just learned, we're gonna do a throwback and try to figure out the domain and the range for this using interval notation. So first, the domain. Since our function goes all the way left and all the way right, our domain is gonna be all real numbers. So negative infinity to positive infinity. Since our function goes all the way down and all the way up, our range is also gonna be all real numbers. So next we're ready to talk about the increasing and decreasing intervals. So first, by these, I want you to write that x intervals is x values for the intervals, and decreasing intervals is also x values. So we're looking at the y values and where my function is going up and down, but we state the intervals in terms of x. Now, folks, if I just look at my sketch here, I would say that it looks like we are increasing from here to here, and then we hit a turning point, and we start decreasing. And then somewhere in there, we hit another turning point, and we start increasing again. So again, I'm reading my graph from left to right. If it's going up, it's increasing, going down, it's decreasing, going up, it is increasing again. So it looks like I'm going to have 2 intervals where my function is increasing and 1 interval where it is decreasing. Now the problem is we don't know where those intervals start and end. What we need to find are these turning points first, and luckily for us, and I'm gonna go ahead and just write zoom fit. That's what we use to get a look at that graph. What we can do is we can use our calculator to figure out these 2 points, because this is going to be a relative max, and this one will be a relative min. Now, relative, because it's not the absolute highest point, because we continue to go up, up, up. And same with this one, not the absolute lowest point, because this part of my graph continues to go down, down, down. So I'm going to need to find these coordinates first before I can decide on the intervals and where my function is switching from increasing to decreasing. All right, folks, so first, excuse me, we're going to go ahead and go back to our calculator graph, and we're going to follow that key sequence that you wrote down in your note packet. So in order to find the maximum and minimum, after you have looked at your graph, you are going to hit second trace, and that takes you to the calculate part of your graph. And then we select minimum or maximum. Now let's go ahead and find this point first, the left one. So we are going to want to find a maximum. So I'm going to select option 4. And now it asks these prompts of left bound, right bound, and the guess. Now, for this, folks, the reason why it's asking these prompts is because your calculator is only as smart as the input that we give it. So if I have a graph like this graph has multiple relative minimums and multiple relative maximum. So to tell our calculator which of these we want to find, we essentially have to set a left bound and a right bound for it to clap and hit the point that's in between those 2 left and right bound marks. So if I wanted to find this one, I set this as the left bound, this is the right bound, to say, hey calculator, why don't you clap those 2 together and find the point between them. So folks, for this left bound, of this maximum point, we just want to make sure that we are far enough to the left of where that maximum is occurring. So somewhere over here, good enough. Same with the right bound. We want to make sure that we're far enough to the right of it because I can't tell exactly where it's at. It's somewhere in there. So I just want to make sure I'm far enough over. Now for the guess, you don't really have to push anything else, but I'm going to go about to the point where I think it's occurring. And my calculator tells me this. Now, your calculator, it's not always perfect, so I don't know why it's giving us that 0.00001, but you can just assume that that maximum is at negative 381. Same with if it said negative 2.9999999, you can go ahead and just round that to negative 3. So now we can go ahead and state that coordinate on our graph, negative 381. And now we're going to do the same thing to find the relative minimum. To calculate on our graph, we hit second trace, which takes us to the calculate tab. This time we're going to select option 3 or minimum. And now it's going to ask those 3 prompts again. So now this time I want to go to the left of my minimum and press enter. To the right of my minimum and press enter. And I'm just going to press enter for the guess, and it takes me to this point. So again, sometimes your calculator just does some weird rounding stuff. We can assume that this is 2, negative 44. All right, folks, so now I can fill in a bit more info on my table. I'm going to go ahead and zoom out here. So for minimums, we can state that we have a relative minimum. And I do want you to state relative or absolute when you are stating those values. We can say we have a relative minimum of y equals negative 44. And on my math lab, it might have you say at x equals 2. So I'm not going to have that part on my answer key, but that's going to help you out with some of the My Math Lab stuff, where it wants you to state that low point, the y value, but also the x value input that gets us to that low value. So there's our relative minimum of y equals negative 44. For our next one, this is going to be a relative max at y equals 81. Also at x equals negative 3. So you don't have to put that on the practice set, but that's going to help you with the My Math Lab part. So folks, we have now found the domain and range, the minimums and maximums, and now we are finally ready to do the increasing and decreasing intervals. So if I look at my graph, let's zoom in again, and we want to find the increasing interval, where does my graph start going up x value wise? It starts going up at negative infinity. Where does it stop going up x value wise? At negative 3. So that x value of negative 3 is where we stop increasing and start decreasing. So negative 3 with a bracket. Union notation. Where do we start increasing again? At this x value of 2 to infinity. And folks, I will say the most common mistake made on this test is with increasing and decreasing intervals. Students will accidentally report out the y value for those intervals instead of the x values. So we're looking at where the function is going up, but we're stating the x intervals where it is doing so. So for our decreasing interval, and the decreasing intervals should be easier because it's going to be kind of our x values that are left over, this interval between negative 3 and 2. So negative 3 and 2. So between increasing and decreasing, and if there are any constant intervals, you should cover the whole span of your domain. So we go negative infinity, negative 3 to 2, 2 to infinity, which covers our whole domain of negative infinity to positive infinity. Now, folks, the symmetry and the discontinuities and the end behavior, we're going to get to those items later in this chapter. So for right now, we're just focusing on the first 6 lines up through minimums and maximums.